On the 19th of June 2014, a major milestone on the road to the construction of the European Extremely Large Telescope was reached. Part of the 3,000-meter peak of Cerro Armazones was blasted away as a step towards leveling the summit. This paves the way for the largest optical infrared telescope in the world. This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory. Cerro Armazones is in the Chilean Atacama Desert. This high and dry site offers ideal conditions for astronomical observations, and the 3,000-meter high mountain was chosen as the perfect site for the European Extremely Large Telescope, or E-ELT for short. The E-ELT is a revolutionary new ground-based telescope with a 39-meter primary mirror. It will collect about 15 times more light than the largest optical telescopes operating today. Once in operation, it will provide astronomers with unparalleled observing power. However, to construct the telescope at the top of Cerro Armazones, a flat area at the summit first has to be created that is big enough to accommodate the E-ELT and its huge dome. As just one part of an elaborate leveling process to help reshape the peak of the mountain, workers are blasting the site to remove a staggering total of 220,000 cubic meters of rock to make room for the 150 by 300 meter platform. A groundbreaking ceremony took place 20 kilometers away from Cerro Armazones at ESO's Paranal Observatory. The milestone event was attended by VIPs from both Chile and the ESO member states, as well as representatives of the local communities, senior officials from the project, and ESO staff. The public were also invited to witness the event online. The ceremony included speeches by the ESO Director General, Tim Dazio, the President of ESO Council, Xavier Barcons, the Intendant of the local city of Antofagasta, Valentin Volta, and the distinguished Chilean astronomer, Luis Campuzano. The order to start the first symbolic blasting was given by the Chilean Vice Minister of National Assets, Jorge Maldonado.
5, 4, 3, 2, 1.
The E-ELT first light is planned for 2024, when it will begin to tackle many of the biggest astronomical challenges of our time. It will aim for a number of notable firsts, including tracking down Earth-like planets around other stars in the habitable zones where life could exist, one of the holy grails of modern observational astronomy. It will also allow astronomers to study the early history of the universe and make fundamental contributions to cosmology by measuring the properties of the first stars and galaxies and probing the nature of dark matter and dark energy. On top of this, astronomers are also planning for the unexpected. New and unforeseeable questions will surely arise from the new discoveries made with the huge new telescope. The E-ELT, the world's biggest eye on the sky, is now on its way.
The European Extremely Large Telescope, or E-ELT for short, will be by far the largest optical and near-infrared telescope in the world. In early December 2014, the ESO Council gave the go-ahead for the first construction phase of the telescope.
This is the ESOcast. Cutting-edge science and life behind the scenes at ESO, the European Southern Observatory.
Astronomy has reached a point where bigger telescopes, much bigger telescopes, are essential to address many of the important unanswered questions. For nearly a decade, ESO has been working together with its user community of European scientists to design such a new giant, the E-ELT. The decision by the ESO Council means that crucial contracts, including those for the construction of the dome and the telescope structure, can be awarded according to plan. The E-ELT will have a main mirror 39 meters across. It will collect 13 times more light than any other optical telescope today. This main mirror will not be a single mirror. Instead, it will consist of 798 hexagonal mirror segments, each about 1.4 meters across, but only 5 centimeters thick. The E-ELT has an unusual optical design, using 5 mirrors. This includes advanced adaptive optics that corrects the fuzziness of astronomical images that is caused by atmospheric turbulence. Adaptive optics are already in use at ESO's Very Large Telescope. By using this technique, the E-ELT will be able to produce images up to 15 times sharper than those from the Hubble Space Telescope. The E-ELT will feature a suite of state-of-the-art science instruments to capture the light that the telescope collects. The dome of the E-ELT is an exercise in superlatives. With a height of 74 meters and a diameter of 86 meters, it simply dwarfs any existing telescope enclosure. The perfect future home for the E-ELT has been found on the summit of Cerro Armazones, a 3,000-meter high mountain only 20 kilometers from ESO's Paranal Observatory in northern Chile. On the 19th of June 2014, part of the peak of Cerro Armazones was blasted away as an initial step towards leveling the summit. Since then, the work on the mountain, as well as on the road from Paranal to Armazones, has progressed well. The construction of the telescope itself will take about a decade. Once in operation, the E-ELT will tackle some of the biggest scientific challenges of our time. It will image planets around other stars and study their atmospheres looking for biosignatures. The E-ELT will also make fundamental contributions to cosmology by measuring the properties of the first stars and galaxies in the universe and by probing the nature of the mysterious dark matter and dark energy. On top of this, astronomers are also, in a way, expecting the unexpected. Surprising results that cannot be anticipated today. The European Extremely Large Telescope will represent a gigantic leap in our ability to observe the universe around us. The world's biggest eye on the sky will lead to a wealth of new discoveries, and it will revolutionize many areas of astronomy. This marks the dawn of a new era.